Hello and welcome to Math200 Statistics Online here at Cañada College. My name is Lapuz. In this video we will go over a problem from Chapter 13. This is from homework 13.1 through 13.3, and this is question number 4. It says that a researcher wants to know if the clothes that a woman wears in the factory is a factor in her GPA. The table shows the data collected from the survey. Women who wear shorts, dresses, jeans, or skirts, and then here are their GPAs. So assume that all distributions are normal, the 4 population standard deviations are all the same, and the data was collected independently and random. They want a 0.01 significance. So here they already set us the null and alternative hypotheses. The null hypothesis says that the means are all the same, and the alternative says that at least 2 are different. So for this study, what are we using? We are comparing the means for these things, so we should definitely be using the analysis of variance, ANOVA. That's what we're doing. We're going to just rely on the computer, in this case Google Sheets, to help us find our test statistic, our F test statistic, and our p-value, and then from there make conclusions. So let us go to our Google Sheets, and here are the very important steps to be able to do analysis of variance really easily with this program. First of all, we're going to rely on an extension. So if you go to extensions and you have your extension here, that's great. But if you don't, we're going to go to Addons, and then we're going to ask Google to get the add-ons. We only need to do this one time, and once it's downloaded onto your computer, then it's there forever, unless you take it out. So we're going to search for it. It's XLMiner Analysis ToolPak. So, or XLMiner Analysis ToolPak. So let's click on that. And you see there's 2 of them. We're going to choose the first one, the one that says Analysis ToolPak, Statistical Analysis for Google Sheets. And so this will create a built-in programming center for you to be able to do your Google Sheets. And so let's install that. Just say allow. We're going to trust it because it is made by Google or supported by Google, and then we're done. And so now it's there. We'll close this window, and now from now until you, for some reason, take it out, when you go to extensions, you will see the XLMiner Analysis ToolPak. Okay? You can get help to view whatever else might be interesting, but let's just go ahead and get started. So when it starts, it'll open up this whole variety of things that we probably could have used throughout the semester, like information about making histograms, regression, paired sample, means, etc. Most of these are built-in programs that they just kind of make into a nice pack here, but lucky for us, the analysis of variance starts with an A, and so we're going to do the ANOVA. And we're going to stick with the ANOVA with a single factor. Now, the tricky part about this is that normally you would think about going to this cell block and then inputting the range, but what you need to do is you need to go to the actual sheet first and click and select the range that you want to analyze. So by clicking here, they can see that there are 4 columns, and then there's some data points in each of the column, and then there's one here blank, but then they'll know that that's an empty cell, so they're not going to account for that. Anyways, once this is highlighted, which it is at this point, I'm going to go to input range, and when I click in there, it's automatically going to fill that. Now you can manually fill this with a range of numbers that you're selecting, but this is all we need to do. This is grouped by columns. You can see the column headers there. If you highlighted the headers, then you would click on labels in the first row, but we didn't highlight that. We just highlighted the numbers, so we're all set. Now, anywhere else here, down at the bottom or off to the side, you can click to view your output. So I'm going to click down here. I'm going to want some empty spaces. And then once my cell is selected to where I want my output to be, I'm going to go click on the output range. And then again, it's automatically going to fill that out. Okay, once you have that, you just click OK. And then you have all this information. So they summarize the groups for you, the column groups. Now, if you would have highlighted the column headers, you would see the group names here. But we didn't do that, so they just call it column 1 through column 4. It finds the count, that's the n, the sum, the average, and the variance. More importantly, this is the actual output that we want. We see the SS between the groups and SS within the groups, which we discussed in the textbook. The degrees of freedom for the numerator and denominator, and then the MS values, the MS between and the MS within, and that ratio between these things. So the MS between divided by the MS within gives you your F test statistic. So this is your test statistic, your actual F test statistic. So that is one of the important values that we want to account for. And then the other one is the p-value. Now, they give us an F critical value, which if we were using a table, then that might be some important information for us. But we are not using that, so we will not need that information. So we can go ahead and select this. I'm going to go ahead and just copy a picture of this so that we don't have to mess around with the formatting. And then let's put it in our notes here. So this is our ANOVA output, and this is these are the values that we want. All right. So our test statistic is the F test statistic, and that's given here. So your F test statistic is 0.89768. That's 0.89768. And rounding off to 3 decimal places, we can call it 898. So 0.898. And I tried putting this into our assignment when it's more than 3 decimal places, and they still accept it. So I think it's okay. Our p-value is 0.44 or 4551. 0.4551. That's 4 decimal places, so that's good. And we can see here that the p-value is a lot larger than our alpha, our significance level. So PV, our p-value is greater than alpha. And with value greater than alpha, we fail to reject. And we're failing to reject the null hypothesis, which is saying that they're about the same. So remember, this is the null hypothesis that we are trying to reject, and we fail to reject that. So they're saying that the mean GPAs are all about the same. So what is our conclusion? There is insufficient evidence to support the claim that the close is a factor for the GPA. I think, and then the other one, there is sufficient evidence to support that the claim that the clothes that a woman wears is a factor. So we can see that there's really not much of a difference what they're wearing, so that the different types of clothes that they're wearing is really not a factor as to how their GPA is supposed to turn out. So it's not this one, it is the first choice. And so we were not able to support the claim, and I guess it would have been good in the beginning if we looked at the actual claim and identified the H1 as the claim. So we were not able to reject the null hypothesis, and so the null hypothesis kind of stands, and that's the opposite of the claim. Okay, that's it. And remember, the main idea here is to interpret the results. Getting the results can be done via our technology, and we did that. So just a quick recap. If you don't have the extensions already, you go to Addons to get the extension and look for XLMiner Analysis ToolPak. And once that's ready, you can go press Start, and then it'll open up this sidebar that has the ANOVA single factor first. And then remember that you want to highlight the values first and then click on these empty boxes to fill them in. And then if you highlighted the wrong thing, you can easily manipulate this, or you can just redo it again. And then press OK, and then you have it running. All right, so there you have it. This is our problem for our analysis of variance. Good luck.